Hi folks, welcome back to Math with Captain Rod. I'm making this video here to demonstrate how to graph trigonometric functions. In this case we're going to take a look at a cosine function. So what we're going to do is we're going to sketch a graph of y equals minus 3 cosine of pi over 4 times x plus 2. A lot of stuff going on. Alright, so before we actually get to our sketch, let's chat about some of the things going on here. So the minus sign here is going to take a standard cosine wave and reflect it. Flip it upside down, basically. The 3 means that this thing is going to have an amplitude of 3. And the plus 2 is going to lift this graph up 2 units. So instead of oscillating around y equals 0, like something like this graph is going to oscillate up higher. It's going to oscillate around y equals 2. I'm going to go ahead and put y equals 2. Well, let's see, 2. Let's put it right here. So we're going to call that y equals 2. And then this graph is going to oscillate around that line. All right, so let's go ahead and talk about the higher and lower bounds. So the amplitude of this thing is 3. So that means that this thing is going to come 3 units lower. So it's going to get as low as minus 1. And I like to put a little something there to kind of mark the lower bound. And it's going to get as high as 5. So let's see here. 1, 2, 3, 4, 5. I guess that'd be here in my picture. Alright, so now let's talk about this guy here. So a standard cosine wave starting at 2, I think what I'll do is, let's do this. Let's put in 0 for x to get the intercept here. And this is going to read y equals negative 3 times the cosine of 0 plus 2. Now the cosine of 0 is 1, so this is equal to negative 1. First point on the graph is here. And the rest of this now has a standard cosine shape. And I'm going to go ahead and sketch it and adjust my scale to the sketch. And the directions here say to sketch 2 complete cycles, so I'll go a little to the left. Let's see, I've got 1.5. Okay, maybe something like that. Wow, that's... I'm going to have to go back here, hold on. It's got to be a little more symmetric. I'm drawing in a direction I'm not used to with my hand. Something like that. So that sketch is going to look something like that. Now that's a rough sketch, a pretty rough sketch, honestly, but I'm going to call it good enough to move on for this example. Now these things say to label a couple of points here. We've already labeled this one. That's the point 0, minus 1. I'm going to go ahead and label this one as well. Now, at this point right here, this occurred when the value of the cosine function was 0. If we were to draw ourselves a unit circle, this point on the graph correlated to this point. This green point on the graph is going to correlate to this angle right here. So at this point on the graph in green, this pi over 4 times x is equal to pi over 2. And if you solve that for x, you get x equals 2 out of that. So this right here is actually the point 2, 2. Now, it didn't perfectly lie on that. Again, this was just meant to be a sketch. And this is supposed to be symmetric. So this distance from here to here is 2. This distance from here to here would also be 2. So this would be x equals 4, 6, 8, and so forth. Not the best sketch I've ever drawn. It should have did a little bit better job as far as making this symmetrical left and right, but I'm going to call it good enough for this example and move on. All right, I'm going to stop that right there.